Okay, we're going to do the fourth CVPM practice problem algebraically. Okay, so we have two runners running against one runner, and the key here is really parsing the situation and figuring out what the distances are involved. There's some sort of unnecessary information here. So if we draw a good diagram, we can get some of that out. So we have relay 1 person here. Gets to there, relay 2 person goes to there. Okay, so we'll call him V1, and we'll call him V2. He's going to have to run a little faster because they're behind. We have our superstar runner. We'll just call his V. Okay, so at this point where they make the exchange, superstar is actually out ahead a little bit, but still trucking along at the same speed the whole time. So what we know is where this superstar is at the point that they make the handoff. He's 250 meters ahead. And we know that they're halfway through, right? So I know that my second runner is running 2,500 meters, while superstar here runs 2,250 because superstar is 250 meters ahead. Really, all the stuff that happened in the first part of the race doesn't affect that portion of the problem. We do want to know about that part of the race because it helps us figure out how fast superstar runs. So we do want to define this interval here. So I will call this D, I don't know, beginning, dB, and this is 2,750 meters, and the delta t is 600 seconds for that one. So we don't know what this, I'll call it D beginning. Okay, so delta t beginning. We don't know what this delta t is for the last part, but we know that it's the same if that comes out as a tie. Okay, so for the second part of the race, we can say that the superstar distance is his speed times that delta t, and that runner 2's distance, which we know is runner 2's speed times that delta t. Now at this point we have, we know both the distances, but we don't know anything else, so we have too many unknowns. We have 3 unknowns, v, v2, and delta t. So we need another piece of information. That piece of information can come from over here. If I look at superstar for the first part of the race, ran a distance dB at the same speed, took a time delta tb. We know both of those, so that I can solve for that v symbolically and substitute it in over here. So the distance that that runner runs is dB over delta tb, this time delta t. Now I'm down to 2 equations and 2 unknowns. I'm in good shape. So I want to get rid of this delta t because I don't care about it. So I'm going to solve for it over here and substitute it in over there. So take this delta t up to the top, bring that down. And substitute it in over here. So d2 is v2. That's the v that we're looking for, times all of this stuff that we're substituting in, delta t, dB, all over dB. Now I know everything in there except for the v2. So v2 is d2 times dB over d times delta tb. Definitely make sure we check our dependencies and units here. So if the runner was further ahead, okay, dB was bigger, and D was smaller, that's going to make this whole thing bigger. So if the runner was further ahead, then the second relay runner needs to run faster because this whole thing becomes bigger. That makes sense. That's good. If the let's say the exchange happened earlier, if these two runners didn't exchange at the midpoint, but the other runner was already 250 meters past the midpoint, then this would become bigger. Again, he'd have to run faster. So that makes sense. And if well, changing the delta t changes a couple of things, so we'll be satisfied with that. Let's check the units. So we have 2,500 meters times 2,250 meters distance beginning was actually 2,750 over 2,250 times that time of 600 seconds. So let's check the units. One of the meters cancels out, and we're left with meters per second, which is good. That's what we wanted. 2,500 times 2,750 divided by 2,250 divided by 600 will tell us 5.09 meters per second. So that's a little over 10 miles per hour. If we look at that as like a 5K time, we run 5,000 meters at 5 meters a second. It's going to take 982 seconds, which is 16.37 minutes. So it's a good clip, and it's a reasonable number for us here.